Hello, Icse Class 9th Physics Chapter Current Electricity. So, in current electricity, the concept begins with the sources of electric current and definition of electric current, charges, and it goes till circuit arrangement and all that. But I think it is good to start the topic of current electricity by the understanding of an atom. So, as we know that atom is the fundamental unit of matter, and if we goes on dividing matter, so we will end up at atoms which can exist in its free state, yet it tries to combine to form molecules. But what does an atom consist of? Still, there are some particles which form an atom. So atom consists electrons, protons, and neutrons. Now, like we know about mass, so also another kind of property of mass is also there, which is called charge. What is charge? I will little later I will explain it, but right now just we know little bit about this charge. When we rub comb over our dry hair, it tries to attract paper pieces. That is charge because it got charged. So electron carries negative charge, proton carries positive charge, and neutron, it is an uncharged particle, neutral. That is why it is called neutron. And one more thing, in an atom, total number of electrons is equal to total number of protons. So this is the basic structure. That is why matter is electrically neutral. So now what happens? Let us suppose we have a block. So it will consist some atoms, and those atoms will have equal number of electrons and equal number of protons. Okay, one more thing I want to tell you, that these electron, proton, neutron are arranged in this way. There is a small region where all the protons and all the neutrons reside, and around this small region electrons revolve. Now this discussion goes into chemistry. I'm not going into it. What I'm interested in, these electrons which are in outer orbits, the electron which are in outer orbits. So if we somehow give this atom some energy, in which form this energy can be? This energy can be in the form of heat, like we rub comb over our dry hair, or it can be in the form of radiation. So sometime it happens, high radiation falls on a metal and uh, it get excited. And some other sources, like some electricity sources. electricity source. I'm not specifically naming it because we have just begun this chapter. So what will happen, this electron will get energy and it will be escaped from this atom. Now, instead of talking about this atom, if I talk about this piece, this block, and somehow we supply some energy into it, so one thing can happen that it may lose electrons. And if it has lost electron, which charge this metal will acquire? So let us suppose it had 100 electrons, so also it will have 100 protons. Remember, proton do not move here and there. They are rigidly held there. Only electron, and that's too, the outer electrons we can move. So let us suppose we have somehow taken out by rubbing or by giving some additional energy, we have taken out 10 electrons. So how many electrons are left now? 90 electrons. So now there is negative 90, and for 100 proton there is plus 100. So simple mathematics leads us to plus 10. So this body will acquire positive charge when it will lose some electrons. In the same way, where these electrons are going? So if there is another object and these electrons get transferred into that object, and let us suppose that object earlier has 50 electrons, so also 50 protons. Now 10 electron more are there. So there are 60 electrons and 50 protons. Minus 60 plus 50, that is minus 10. This will acquire negative charge. This is how charge transfers. So well, it is just experimental observation that some object acquire positive charge, some acquire negative charge. Like if we rub a glass rod over wool, then glass loses electron and acquires positive charge, and wool acquires negative charge. Now there is a wood called ebonite. So if we rub ebonite rod on the wool, then what happens? Then in this case, ebonite gets negatively charged and wool gets positively charged. So we can't just memorize which will acquire positive or which will acquire negative. It also depends upon which body is losing and which body is gaining electron. So you can search out for those materials which acquire positive charge after rubbing over other object, so that object will acquire negative charge. So there can be several combination of that. So this is all about charge, but what is the conclusion in that? The conclusion is electron only transfers. Either a body is getting positively charged or negatively charged. The thing is, the transfer of electron is taking place, not the proton, because proton is tightly held inside the nucleus. So keep this thing in your mind. Whenever now we will talk about flow of charge, So we will simply think about electrons, nothing else. The question is, what is charge? So we can say the charge is the property of matter which gives rise to electrostatic forces, or which is responsible for electrostatic interactions. So we have a general formula for charge, Q equal to Ne, where N can be 0, plus minus 1, either plus or minus, plus minus 2, because charge can be positive as well as negative. So it is simply integer, either positive or negative. And what is this E? Most of the students think that it is electron, but E is called elementary charge. What is elementary charge? It is the least possible charge. It has value 1.6 into 10 to the power minus 19 coulomb, where coulomb is the SI unit to measure charge. Now remember, for electron, charge for electron is negative of this value, and charge of proton is positive of this value. In this chapter, whenever we discuss about electric current, we will use the term charge, and when we will measure charge, we will not put negative sign there. So don't get confused. It doesn't mean that proton is flowing. I told you earlier that only electron flows. Only electron is responsible for electrifications. So unit of charge is coulomb. So there are some properties of charges. Like first thing, charge is conserved. So charge can neither be created nor be destroyed. So if there is charge, so it can transfer from one body to other body, but it can't be created. Second thing, like charges repel. We know that. Unlike charges attract. We know about it. So positive positive repel, negative negative repel, and positive negative attract. Next concept is electric current. Now what is electric current? See, whatever we discussed earlier, that was all about charges, and what we are familiar with in terms of properties of charges, like rubbing a comb over here and it is able to attract paper pieces. That is, all these things are limited up to static charge, charge at rest. But what happens when charge flows? So when charge flows, then it forms electric current. So how to define electric current? The rate of flow of charge is called electric current. What does it mean, rate? Actually, whenever in physics we talk about rate, it means something which is divided by time. So I equal to Q upon T, charge divided by time. So it is rate of flow of charge. So its SI unit is ampere. Denoted by A. Remember one more thing, that current has a direction. Its direction can be assigned by as follows. Number one, from positive terminal of a cell or battery to negative terminal of negative terminal. First thing, its direction can also be defined as from higher potential now. What is this potential? We will just understand it in later sections. From higher potential to lower potential. Third, and remember, we are not talking about potential energy, it is potential, a new term in electricity. Third, along the direction opposite to the direction of flow of electrons. So if electrons are flowing in this way, then direction of current will be in opposite way. It is just because earlier it was believed that positive charge flows and direction of current was assigned, but later on it came to know that positive charge, not the positive charge but negative charge flows, and that is why, keeping those old tradition in mind, they just continued with that by supposing that positive charge flows, but as negative charge, that is electron flows, so direction was taken opposite to the direction of flow of electron. One more important thing, current has magnitude, I has magnitude as well as direction. So in the early discussion in your previous chapters, there was a concept of vectors and scalars. So the physical quantity which has magnitude and directions are considered as vector, but current has magnitude as well as direction, still it is a scalar quantity. Now why is it so? It is because there are some other requirement of a physical quantity to be called a scalar, a vector, and that is the addition rule. So as current is added or subtracted algebraically and not through vector addition rule. Right now, it is not required for you to understand vector addition rule, but just keep one thing in your mind that vectors are not directly added or subtracted. They have a different algebra for that. That is called vector algebra. So, scalar quantities are directly added and subtracted. So, current is also. That is why it is considered as a scalar quantity. Now, next question is what makes current to flow? The answer is potential difference. Now, what is that potential difference? Oh, many students will think that it is cell. Yeah, it is cell or battery, but what that cell or battery is delivering? That is delivering a potential difference which makes current to flow, charges to flow, which turns into a current. All right, so in order to understand what is potential difference, first we will understand what is potential. And on other side, I will write about potential difference. Its symbol is V. Its symbol is also V, but sometimes it is written as delta V also. Delta V, VAB, or simply V. So potential at a given point is equal to amount of work done. In shortcut I use AMT for amount of work done and WD for work done in moving unit, means value 1, positive test charge from infinity to that point. Now it is a bit complicated. What does it mean? Actually, this is the definition of very higher level. So in class 11th and in higher classes, you will easily understand this. But casually, what I would like to explain about this is potential is something, some kind of stored work. Just keep this thing in your mind. So the place where that stored work is high is called higher potential, and the place where it is um, bit lower is called lower potential. So that is how potential, there is a difference in potentials, and thus there is a potential difference which causes current to flow. So there is a formula for that, V equal to W upon Q, and unit of V is volt. So volt is also symbolized as V. So this is, I hope, first physical quantity in physics which is that much simple. Symbol is also V and unit symbol is also V. But it is very complicated one. Now what is potential difference? First we will define potential difference. See here, potential at a given point, potential at a given point, but potential difference means we have to subtract two terms. Potential difference between 2 points is equal to amount of work done. All right, same thing is there in moving unit positive test charge from C. Now the thing will change, not infinity to that point, from one point to other point. So infinity to that point means we have brought it from very far off. And here we have brought it from far till this point, and now from this point to this point. So we will find the difference between them. That is why potential difference. Formula is simply, we actually will write it as delta V, we will write it as VAB. Why? Because it is, we are obtaining it by subtracting two potentials, or simply we can say that it is V. In general, we will use the term V, so there can be a confusion between both of these, but they will never ask you that to find potential and find potential difference. If they do so, you can, at that time you can put that delta or subscript AB. Otherwise, go with this V, no problem with that. W upon Q. What is the difference? This work from infinity to that point, and this work from one point to other point. This is only the difference. Unit is same, volt. Why? Because it is just the difference. Like if I subtract two length, still it will be measured in meter. Still it is length. Now what potential difference does? Potential difference gives us an idea in which direction current will flow. As I told you earlier when I discussed about current, that from higher potential to lower potential, this is the direction of current flow. So if we are able to find potential difference, we are able to distinguish higher potential and lower potential, so we can assign the direction of current flow from higher potential to lower potential. Next, the question is, what is the source of electric current? Electric current. So the source of electric current is something. The answer is the system which produces potential difference. And if they want some examples for that, so we have examples for that. Give examples, let us suppose. So we have examples like cell, like battery, like dynamo. Now what is dynamo? Dynamo is electric generator. It can produce two types of currents, alternating and direct. So yeah, let's discuss about these cell, battery and dynamo. But generally we don't use the term battery. Instead, we use, for cell, we use the term primary cell, which is ordinary cells, and for battery we use the term secondary cell, that is battery. And what is dynamo? Dynamo is slightly different. I hope you people have often seen um, the dynamo or generator which runs through engine, and whenever there is power cut, well, I'm not talking about that UPS or inverters. I'm talking about dynamo which runs, makes a huge sound, and then produces electricity. Well, we'll discuss about it later. First we'll focus upon primary and secondary cells. So, the electric cell, the device which converts chemical energy into electrical energy, is called electric cell. So, we have primary cell and secondary cell. Primary cells are those which cannot be recharged, and secondary cells are those which can be recharged. In primary cell, there is a simple arrangement of positive and negative electrodes, terminals of a positive and a negative electrodes. Here, a set of positive and negative terminals or electrodes is there. Primary cells, like ordinary dry cells which we often use, dry cells, of, there are some others also called Daniel cell. There is Leclanche cell. Oh, don't get troubled. Okay, you need to just memorize few names. So dry cell you have seen, I hope, in our torches, not those rechargeable, uh, in which we have to insert cell. So that is dry cell, and it consists a chemical, so through which charges flow and it supplies current. So here example is lead accumulator, which is also called lead acid battery. And also nowadays nickel cadmium batteries. So such are secondary cells. So both of these cells produces DC, that is direct current. Well, in current section we didn't discuss about it because they are not so I mean, they don't have some wide application in your syllabus. So, but just in order to tell you about DC and AC, I will give you a quick distinction between them. So, current, oh I current actually, uh, current current I, we can divide current into two parts. One is DC, which is called direct current, and other is AC, that is not air conditioner, it is called alternating current. Both has same short form, alternating current, but both are different. So DC has steady value, it has fluctuating value. Alternating positive and negative value. Its graph can be shown like this. If with respect to time, if current is in this direction, time is in this direction, so this is its graph. But for alternating means changing, and in positive and negative, so it looks like this. Steady, this direct current, its source is cell, battery, and DC generator. There is a DC producing generator also. Its source is only AC generator. So actually in our daily life there is no DC generator. They are especially for special purpose they are manufactured, but in our daily life there are AC generators. You have often seen in marriages and some other kind of functions, so they use AC generators. All right, so now we will move to once again the basic discussion about current, voltage, and all that. Now, before we proceed any further, there's another term which is called resistance. What is resistance? So, the term resistance comes from some kind of opposition. So, when current flows through a body, the electrons get collide with the constituent of that material, that is molecules or atoms, and thus the flow get resisted. So now what happens actually, some of the materials offer greater opposition and some of them offer lesser opposition. On the basis of that, we divide substances in accordance with different categories like conductors, insulators, semiconductors, superconductors. So we can easily classify them if we know about resistance. So now what is resistance? So the obstruction offered by the body in the flow of current is called resistance. This is just the meaning of that resistance, but if we want to calculate it, then R equal to V upon I. So it has a unit which is called ohm, and its symbol is a Greek symbol like this. It is Greek alphabet omega. and we have to put this instead of writing ohm, or if you want you can write entire ohm there. So now the thing is, on what factor this resistance depend? Factors affecting resistance. So there are four factor, uh, pardon. First, length of the body. Second, area of cross section of the body. Third, temperature. And fourth, material. Means what are its constituents. So on how how does it depend upon length? So resistance of a body is directly proportional to length. It means if L increases, if we use longer wire, then resistance will also increases. Now here, in terms of area of cross section, it is inversely proportional to area of cross section. It means if area of cross section increases, then resistance decreases. We can take an intuitive example for that. If there is a long road and crowded road, so we will face more difficulty to cross this. And here, so more difficulty means more resistance, and here if area is more means if road is broader, so we will not have that much of crowd here. So the same crowd which is there, but it is scattered now because of broader path. So area of cross section is more, that is why resistance is lesser. Now in terms of temperature, so temperature for conductors, when temperature increases, resistance decrease, resistance also increases. It is due to some disturbance there because of high temperature. But in terms of insulators, when temperature increases, resistance decreases. Now why there is not that kind of problem which happened here? So in insulator there are very less amount of free electrons. So if temperature increases, there are more free electrons and it become more conducting, so resistance decreases. But in terms of conductors, if temperature increases, so already it has free electrons, so there is a random motion in those electrons, so their conduction does not increases, however it decreases because they do not flow in a proper way. Next thing is material. Like we have divided conductor and insulators. Among those conductors, different conductors have different um, conducting ability, so they offer different resistance. So there is another term which is called resistivity, which is more specific. Resistivity, which is more specific to explain about the conductive property of or resistive property of a material. So this is a new symbol called rho. It is RHO, rho. So again, Greek alphabet, and we use it for resistivity. So we know that R is directly proportional to L, and R is inversely proportional to area of cross section. So R is proportional to L upon A. And you know, when we remove this proportionality sign, we put some constant. Here the constant is rho. So it is rho L upon A, where rho is called resistivity. Actually, resistance does not tell about more specifically about the materials, but this resistivity, Ra upon L. Though there are A and L in this formula, yet this resistivity depends upon temperature and material only. Why is it so? You will come to know in senior classes. So I don't want to explain it here. If you want its answer, you can watch my videos for class 12th. Anyway, so here it depends upon temperature in the same way as resistance does. So for conductors, if temperature increases, then resistivity also increases. And for insulators, if temperature increases, then resistivity decreases. And in terms of material, different material have different resistivity. Its SI unit is ohm meter. Next, I'll proceed to next topic, but before that, we need to understand and memorize some symbols, electric circuit symbols. This is the short form of circuit. Don't get amazed with this K is coming. It is just in pronunciation. So electric circuit symbols. So this symbol, a longer plate and longer line and shorter line. This line is positive, this is negative. It is used for cell. And if there are more than one such cells, then we call it battery. Now there can be many of them also, so I'm just saving my time making two only. Next, there is an on off switch. So this is how a switch look like. So this time it is in off state, off switch, and when it touches, then it is on switch. I mean on state of switch and off state of switch. Switch can also be called key, but for key we have a different symbol. So this is off key and this is on key. We have to put a dot in between it. This is on key. There is a tap key also. You have often seen, like in doorbell, there is a bell, there is a key which we press and it comes back. So that is it is called tap key. And there is, this is called resistor. What is a resistor? Generally, any device which consumes electricity is called resistor, like a heater, like a bulb, and they're in a circuit sometime to consume that electrical power. Electric resistors are connected. So a resistor is not a bad thing. It consumes electricity, and hence it resists the current, and by its resistance it consumes electricity. Resistor doesn't mean an insulator. Resistor means a conductor which is offering some resistance, some oppose. That is why we called it resistor. So a common uh, conducting wire is not a resistor. However, it also resists, but a resistor is something in which that electrical energy is being consumed, like electric iron, like rods, like electric lamp, and etc. So this is a resistor. So we use this zigzag line to represent it. And there is another symbol, and there are two symbols, both represent same thing. So both represent same thing. Now either this way or that way, we call it rheostat or variable resistor. As you can see, that speed controller of fan, that is also a rheostat, because we set it at different positions. So indirectly we change its resistance, and hence the speed of fan get controlled. When we put it at high resistance, then it consumes more electric potential, and then fan gets very less, and it runs slow. And when it uh, takes less offers less resistance and takes less electric energy, then uh, fan runs faster. So that is a variable resistor. Other than that, there are two measuring devices. One, ammeter, positive, negative. Positive, negative just meant to connect it. It indicates that this side you have to connect toward positive side, and this side you have to connect in negative side. It is called ammeter. That is, it is used to measure current. And another measuring device is voltmeter. So I hope you are getting it. It is used to measure voltage, but we will use the term potential difference. And see, ammeter is connected in series combination, and it is connected in parallel combination. Parallel means laterally. I will explain it in upcoming diagram. Next is Ohm's law. Now what is the Ohm's law? Ohm's law is the relation between current and potential difference. So the current flowing through a conductor is directly proportional to potential difference applied across it. keeping other physical conditions constant, like pressure and temperature. So if we keep pressure and temperature constant, then current flowing through a conductor is directly proportional to potential difference. I will write it in reverse order: V proportional to I, and when we remove this proportionality sign, we put a constant. Here that constant is, it is not any constant, this constant is resistance. So this is the entire formula for that, and we need to draw a graph accordingly. So if we draw plot V along x-axis, I along y-axis, so the Ohm's law graph has a property: it starts from origin and has slant nature, constant slope. Its slope does not change. This is what Ohm's law signifies. And uh, in order to experimentally verify this law, we have to draw a circuit. So that circuit includes a cell or a battery, whatever you wish to draw, or whatever you are asked to draw. So there will be a key, we will switch on it, we will have a rheostat to vary this potential difference, and we will measure current also. Here we have ammeter, we will connect positive. It is not that positive repel, it is a symbol that you have to connect this positive to positive terminal and other to negative. It will come from here, and here we have that device, that resistor, whose on which we are verifying this Ohm's law, and across it we will apply potential, this voltmeter, positive on this side, negative on this side. So as I told you earlier that this ammeter is connected in series and this voltmeter connected in parallel. It means like this: it is connected in the main line and it is connected sidewise. So this is how Ohm's law works. So this is the all the theoretical topics in this chapter. So there are some numericals also. So for those numericals I will make a separate video, and if any topic I have missed, let me know in the comment section. I hope this is helpful for you. Thank you. Keep studying. Bye.